Hi everybody. I wanted to make a quick video to show you how to use Rguroo to find probabilities involving the central limit theorem. So I've pulled up an example that we already worked in a previous video, but when we did it, we used the TI calculator with the normal CDF function. I'm going to show you how to do the same thing, but with Rguroo. Again, this is a problem involving central limit theorem. So example 1, college age, says the mean age of college students in 2008 was mu equals 25 years, with a standard deviation of sigma equals 6.8 years. A simple random sample of 64 students is drawn. What is the probability that the average age of the students in the sample is greater than 26? So we've got a sample size bigger than 30. We're finding a probability regarding basically the sample mean, that the sample mean would be greater than 26. So this is definitely central limit theorem. And so the biggest difference is that when we use central limit theorem, our standard deviation is actually the standard error, which is the population standard deviation divided by the square root of n. And you can see how that's the last thing we put in when we use normal CDF with the TI calculator. So with Rguroo, you have to type this in as well. But unfortunately, when you type in SQRT for square root and then 64, it gives an error, unfortunately. So let me show you a workaround. Okay, so we're going to go to our probability calculator and choose continuous. We're going values to probability, normal distribution. The mean was 25. Now, the standard deviation for the population is 6.8, but what we have to remember is, because this is central limit theorem, we have to put in the standard error, which is 6.8 divided by the square root of the sample size, which is 64. So, like I said, you can't type it in like that. You can't type in 6.8 divided by square root of 64. It will give you an error. I actually got it to work a couple of times, but most of the time it kicked back with an error. I couldn't get it to do it consistently, so I had to find a workaround. So here's my workaround. So on the left-hand side, you have all these different options. The last one is applets and calculators. And somewhere under the applets list, you'll see calculators. So you can see mine here, calculators. It says Desmos. So if I expand that, there's a scientific calculator, a four-function calculator, and a graphical calculator. Any of these three will work. I'm just going to click on scientific calculator. Now, my box went away, but it's still there. I can toggle these two tabs. I can toggle back and forth between these two, and I can get back to my little box there. But I'm going to use the calculator to figure out my standard error. So I'm going to type in 6.8 divided by the square root of 64. And on the right-hand side, you can see that this is 85. And so what I'm going to do is I'm just going to copy it, and then I'm going to toggle back over here to my continuous distribution probability calculator, and I'm going to paste it into my standard deviation. Now, obviously, I can type in 0.85, no big deal, but a lot of times when you do this calculation, there's a lot more digits, so it's definitely easier just to cut and paste there. And we're finding the probability that the sample mean is above 26. Hit graph, because I like to see the graph. And we see that it is 0.1197. Let's check it out. Same exact thing that we got before. I wanted to do one where we used INV norm. So let's do this one here. The real estate group NY reports that the mean monthly rent for a one-bedroom apartment without a doorman in Manhattan is $2,631. Assume the standard deviation is 500. A real estate firm samples 100 apartments. Let's skip to part C. Find the 60th percentile of the sample mean. So 60th percentile, they're giving us an area. They're giving us the basically the proportion to the left of the 60th percentile. So the proportion to the left of the 60th percentile is 60%. So we can go back to our calculator and go to basics. And I'm going to clear all of this out. And actually, I'm just going to click on probabilities to values. That's what we actually need to do. And then let me go back. The mean was 2631. 2631. And the standard deviation is 500. But the sample size is 100. So going back here, click on my scientific calculator again and clear all. I'm going to do 500 divided by, and this one's going to come out nice, the square root of 100. And the answer is just 50. So cut and paste your 50. Oops, toggle back over here. Cut and paste 50 right here. And we're doing the 60th percentile, so that's lower tail 0.60. And we see that it's shaded in the lower 60%, and that would be $2,643.67, which looks like exactly what we got here. Okay, so that's all I wanted to show you is how you could use this scientific calculator to help you get the standard error and then just paste that into your standard deviation. Because again, when we use central limit theorem, we replace standard deviation with standard error. So I just wanted to show you that quick, easy way to do it. And if you have any questions, let me know. All right, have a great one.